Welcome to the Sudanese Orthopedic Surgeons Association. SOSA presents the Biomechanics webinar.
And I will outline the technique for insertion in the bone. If we ask about what is a screw is a mechanical device that converts the rotational force torque into linear movement. يعني when we are doing screwing, this thread or this rotational force lead to linear advancement, linear movement or translation. This in diagram, and this is the diagram. We do torquing or screwing, rotational force that lead for translation. And the screw is designed as a core about which is wrapped a spiral surface. It's a core like this with a spiral surface forming the threads. Can you draw a screw and label various parts? يعني in another way, the part of the screw, the anatomical part of the screw or the design of the screw. We have this is the head of the screw, and this is the core of the screw, the area without the spiral surface or threads, and this is the threads, the outer surface, and this is the tip of the screw. Can you describe different parts of the screw and their functions? This is the head. We have a description for this. This is a round area in the upper part of the screw. We have different shape. افتكر now all of يعني اغلب السكرو in orthopedic practice are hexagonal. هنا استريكسس، هنا زي ما قال 1 او ستار، لكن اغلبها حاليا or most of the screw are hexagonal head. And the head function to attach a rotational device or screwdriver and to arrest forward motion by these shoulders, like shoulder, to stop the forward motion and to attach to the rotational device like screwdriver. Some screw head have a third function. When we have threaded head, like this threaded head, the development of threaded or locking head has allowed screw to lock into threaded plate hole and by creating an angularly stable construct, as discussed by Mr. Huzaifa in locking plate, locking compression plate. This area is the head. Below the head, this area is called run out, and this is a transitional area between the shaft and thread, the lower part, where the screw breaks. Sometimes this run out or a shaft, after the run out, then head. This is a run out. Before the thread, there is area is called the shaft. And the shaft is a smooth link between the head and thread area. If we have partially threaded screw, we have a long shaft. If we have a fully threaded screw, we have a short shaft. How does tightening the screw create compression? When the screw driving fully, the head contact the underlying bone and resist further longitudinal movement. If the screw is then rotated a fraction further, that means in other words, tightening, the threaded portion try to advance and this create a minute stretching of the screw. You can say some stretching in this screw metal بتكون very micro change in the stretch of the screw, and this is result in tensile force in the core of the screw. This is balanced by equal compression force at the screw head bone interface. This area, there is equal compression force at the screw head bone interface. Screw head and bone interface. Why should we uh, count countersink the cortex beneath the cortical screw head? We can say syscortex. الcountersink يعني is better to countersink. As we said as Mr. Bashandi said in the first lecture about the stress and strains and the definition of biomechanics, stress is equal force per unit area. Okay. If no counter thing, the area of compression is small. This is the area of compression اللي هي قلنا screw head bone interface compression force. Here the area of compression is small. And if it is small, that means high stress. So increase risk of bone failure. When we do counter think in the cortex, the area is become larger. And you know the unit area inversely proportional to the stress. So the stress become less and decrease the risk of bone failure. What would you do if the underlying cortex is thin؟ في حالات دائما الكانسلس بون يعني يكون الكورتكس very thin like metaphyseal fracture or distal femur fracture like that. Here we use with cancellous screw, which are used largely in the metaphyseal and epiphyseal side. The underlying cortex is too thin to countersink. يعني هنا ما حنقدر to do countersink. So if we try to countersink, the head compresses the cancellous bone beneath it, and it may fail, being much less resistant to high strength than thick cortex. What we do to increase it to countersink, put a use of washer. In simple Arabic, وردة. استخدام الوشر which increase the area over which the screw head compression is for, so reduce the stress there, lead to decrease the stress, the risk of failure. So it's better to do countersink in case of cortical bone or to use the washer in area of cartilage bone. You know now what about the diameter, the part of the screw? So now we discuss the diameters. We have diameter in the screw. Number one is the core diameter. The core diameter, this is area in this diagram, is the smallest diameter in thread section. Thread section is the solid section from which the thread projects. This is a thread. So the smallest diameter is called the core diameter. And the diameter of the core determines the minimal hole size would permit the screw to be accommodated in the bone. And so determine the drill used to create the pilot hole for the screw. يعني what is the drill bit diameter used depend on the core diameter. هنعرف الكلام ده later إن شاء الله. The outside or thread diameter, the outside diameter as illustrated here, determining the minimal size of any hole through which the screw will glide without thread purchasing in the bone. And this is sometimes known as the nominal diameter of screw, as the screw are often named by this dimension. What do you mean by that? If we say we have 3.5 cortical screw, now we mean the outside or thread diameter, not the core diameter. 4.5 cortical screw, that means the outside diameter or thread diameter is 4.5. So it's called the nominal diameter. 6.5 cannulated screw, that means the outside or thread diameter is equal 6.5 millimeters. The diameter also we have the shaft diameter, and we say that shaft diameter, the area between the head and run out and the thread area, and differ from partially threaded screw and fully threaded screw. Thread geometry. Now we pass from the part diameters. Now we call about the geometry. The geometry of the thread, we have what is called thread pitch, the distance between the thread. The shorter distance, that the mean finer pitch. The longer distance, that means coarse pitch. We have also areas called lead. The lead is the linear distance traveled by a screw for one complete 306-degree turn of the screw. When we turn the screw 360 درجة, the distance that passed by a screw is called the lead. The lead. Also, we have thread depth. Depth, this is the outer side of the thread, and this is the inner side of the thread. The depth or effective, usually we talk about the effective thread depth, the actual thread depth. And the effective thread depth is half the difference between the thread diameter, اللي هي outer diameter, and core diameter. Outer diameter minus the core diameter divided by 2 is called the effective thread depth. And the thread depth determines the amount of contact with the bone. That in turn determines the resistance to pull out. According to the thread geometry, the cortical bone screw have a fine pitch. And the pitch, the area between thread and above, the near part thread, two threads near together. If we have a fine pitch, a small thread diameter has a fine pitch. In cancellous bone, we have a coarse pitch. Here, the thread or the pitch is large pitch. The screw working distance or working length, defined as the length of the bone traversed by a screw. The finer the pitch, the more turn that will have to make to insert the screw, and more turn of the spiral thread engage in a given depth of cortex. The more thread engage in the cortex, the greater the pull-out strength. Look at this 3 types of screw. This is a fine pitch screw, cortical screw. It differs from this lock screw, which we have the core diameter is bigger, but we have a small pitch, or a small pitch that means a very fine pitch. Differ from the cancellous bone, which have a coarse pitch or need a less turn to advance the screw. The pull-out strength. Pull-out strength is proportionate to the outer diameter. The larger the outer diameter, the greater the resistance to pull out. Square of outer diameter is proportional to the pull-out strength. Okay? The thread depth determines the amount of contact between the bone and the screw, that in turn determines the resistance to the pull-out. The more thread engage in the cortex, the greater the pull-out strength. وما تنسوا thread depth, it means the effective thread depth اللي هي the outer diameter minus the inner diameter divided by 2, the core diameter. The bending strength of the screw. We know the forces that encountered by the material, like torsion, bending, axial, and so on, shearing, and so on. It is that force that affect on the metals. The bending strength of the screw, bending strength is proportionate to the core diameter. The larger the core diameter, the greater the bending strength. Cube of the core diameter is the proportion to the bending strength. That means the bending strength proportion to the third force of the core diameter. In this screw, we have the outer diameter, equal outer diameter for both for these two screw in the diagram. The left one, we have larger core diameter in contrast to the right one. So this metal or this screw have a higher bending strength more than the another one, and the proportion is cube of the core diameter. That means the third power of the core diameter. بالعربي الكور diameter أس 3. Increasing a core diameter by factor of 2, that means 2 by 2 equal 4, 4 by 2 equal 8. So 2, 4, a third power of 2 is equal 8 times greater. How can you maximize pull-out strength? So increase the outer diameter. This is the outer diameter. Decrease the inner diameter. This is the pull-out strength, not the bending strength. The inner diameters. That means increase the effective thread diameters. So I'll increase the thread density. يعني نقلل البيتش. يعني الفاين بيتش screws had high pull-out strength more than the coarse pitch screw. Increase thickness of cortex. Yeah, and use the cortex with more density and using locking screws. Tip. We talk now about the tip of the screw. The screw tips are of the three major types. We have the standard one. This is the standard one. Round tip screw need a drilling of a pilot hole and then tabbing the creation of the thread in the bone by the use of separate threaded cutting tool tab. That means when we need to put this screw, first we use the drill bit, and after that we use a tab, threaded tab to form or to create the threads. After that we advance or putting the screw using screwdriver. We have another type of tip is called self-tabbing. Here we need pre-drilling only by pilot hole to do a pilot hole, but we create its own thread in the cortical bone by virtue of cutting fluids as the tip. This is a cutting fluid. We have another screw is called self-drilling screw. Require no preparation of the bone before insertion. No need for drill bit to do a pilot hole. No need for a tab to create a thread. We go directly to put the screw. The length of the screw, the nominal length of the screw from the top of the head here to the screw tip. This is a nominal. What do you mean by nominal? We nominal that the screw we have cortical screw 3.5 with the length 23. That means from the top of the head to the end of the tip, this is the 22 millimeter, 24 millimeter, and so on. An appropriate length of screw need to be chosen. Here we have good lengths. Here we have two short lengths. Usually we need just less than 2 millimeter beyond the distal cortex in the bone. يعني ما يفوت لنا just like this is a good. Here very short, that means then less than 1 millimeter beyond the distal cortex, and here is very long when we have more than 2 millimeter beyond the distal cortex. Describe different types of screw. These are the different types we have here. Cortical screw. Sometimes we have stainless steel versus titanium. Mr. Bashandi Mashkur talk about what the different type of my materials. Sometimes we have partially threaded screw versus fully threaded screw, cannulated screw, non-cannulated screw, locking screw. We have a threaded head and non-locking screw. Describe different type of screw. Sometimes we have cortical screw. In the cortical screw, regarding the pitch, had a smaller pitch, so greater number of thread and better purchase. Regarding cancellous screw, had a large pitch, so less number of threads, greater thread depth. In the cortical screw, the tip is blunt ended, and in the cancellous one, we have spiral ending tip. What are the steps to introduce a screw into a cortical bone? First, we do a core or pilot hole by using drill bit. After that, we do countersink, and we know what are the effect of countersink that increase the surface area of contacts between the bone and the screw that decrease the stress. After that, we do a tap, and the tap to create the outside diameter or to create threads in the bone, then advancing the screw. What are the principle of lag screw fixation across the fracture side? همشي فيها سريع because it discussed in the previous lecture. Usually the thread must not purchase in the inner fragment, and so the gliding hole must be drilled in the near cortex. Here we do the step 1, we do a gliding hole here. Okay, the thread of the screw must purchase in the far fragment. عشان كده دايما الدريل بيتس size in the proximal hole or the gliding hole is the larger than the distal one. So here there is no purchasing, only gliding. And here we have the screw should be purchased in the far fragment. And step 3, there must a screw head to arrest the progression. يعني we have to need some resistance for the screw head to progress further in the gliding hole. In the cortical screw, you have to look this. The core diameter, if we have a screw 4.5 millimeter, that means this is the nominal diameter. النومينال diameter زي ما اتفقنا عليه هو الاوتر diameter اللي فيه الثريد. معناتها the outside diameter 4.5 millimeter. The inner side millimeter about 3.1 to 3.2. So if we need to put this screw, you use drill bit 3.2 to do a pilot hole. After that, we use the tap to create the threads. After that, we advance the screw. In 3.5 or 3.5 cortical screw that using small fragment sets, the core diameter about 2.4 and the outer diameter, or which is called the nominal diameter, 3.5. What are the principle of lag screw fixation across the fracture side? أفتكر دي we discuss shear resistance and interfragmentary compression. If you put the screw in this interfragmentary like this screw directly, يعني زمان classical teaching we used to do in perpendicular to the fracture side. If you put directly like that, this will lead to maximum resistance to shear. And if like this, and if you use in the gliding hole perpendicular to the fracture side that maximize the interfragmentary compression. These competing objectives can be managed in one of two ways. The theoretical option, firstly, two screws can be inserted, one perpendicular to the bone long axis that make maximize the shear resistance, and another one should be perpendicular to the fracture side to maximize the compression force. And this is, I think, theoretical. The other option is to produce a maximum desirable interfragmentary compression with one or more screw perpendicular to the fracture plane, and then achieve resistance to shearing by using plate to protect the primary screw fixation. ودي اتكلموا عنها بشندي وحذيفه كتير جدا, was called protection or neutralizing plate. So this the function of the plate can be done by the surgeon. Some precautions. Very important when we do interfragmentary screw, the gliding hole اللي هي the proximal hole, and this is the fracture, and this is the proximal side. The gliding hole, then, as I say, it comes in the larger diameter than the distal one, the pilot hole. To glide the screw smooth, then to be purchased in the distal part, نعمل لنا interfragmentary. Very important, the gliding hole should be coaxial with the pilot hole. And very important, in the interfragmentary fixation, the fracture reduction is maintained. Look, if they have a gliding hole not in coaxial with the pilot hole, lead to screw failure. And if the fracture reduction is not maintained during screwing, will lead to mal reduction. النقطة المهمة, no gliding hole, that means no interfragmentary compression. يعني يا جماعة ما نفس الدريل بيت. أنا ملاحظ إنه some surgeons you use the same drill bit to put the interfragmentary screw without make this the gliding hole, and this is a pilot hole for purchase. Another thing, cancellous screw. If we say 6.5 cancellous screw, usually in the partial threaded, the inner diameter 3.5, the outer diameter is 6.5, the normal diameter, and the shaft diameter usually 4.5. Here, the drill bit used for pilot hole is 3.2 millimeter. In cancellous screw, 3.5 cancellous screw, the inner diameter about 2%, 2 millimeter, and the outer diameter is nominal diameter 3.5. Usually we use drill bit of 2 millimeter. In the screw design of cancellous screw, partial threaded or fully threaded, we have three different designs. Fully threaded like that, partial threaded like this. That means it's called 32 millimeter partial threaded, and this is 16 millimeter partial threaded. We have some special screw like Herbert screw. In a small bone such as the scaphoid, self-compression dual pitch screw can be used. These are usually cannulated as the fine pitch of the thread on the head, this is a fine pitch, engage the bone. It travels less far on turning than the coarse pitch tip, and so compression is applied across the fracture side. يعني الهربل سكرو dual pitch, headless. The head, the proximal part of the screw is the fine pitch. The distal part of the screw is coarse pitch. What are the functions of the screw? To produce interfragmentary compression and to attach implant to the bone by compressing them into the bone surface, to attach implant to bone producing angular stability like LCB, to hold two bone in correct relation like using position screw, like what we use in syndesmotic screw. It's called position screw. And to lock an intramedullary nail to the cortex when using in the intramedullary nail, to block movement of the main fragment around iron nail like here اللي هي بيسموها البولر سكرو. استخدمها مرات when we have a proximal third shaft of tibia fracture. Sometimes we put polar screw to prevent recurvatum or varus malunion. Okay, thank you. This is regard the screw function. We have a last talk about the intramedullary nail. اوكي ثانك يو بشندي. طيب عشان الناس ما تنسى حنمشي عشان ما تسحج كده وحنمشي اسرع شويه ان شاء الله. Nail biomechanics. If I ask you about what is the diagnosis here, usually we can say this is a broken interlocking nail femur with non-united fracture. This is a shaft femur. So we have to know the functions and the functions and designs of nails and the forcing active on the nail to discuss the factors that lead to the previous diagnosis. How does an iron nail function? Usually it functions as internal splitting. External splitting with load sharing characteristic. And what do we mean by internal splint? That means splinting is defined as a construct in which micromotion can occur between pole and implant, providing only relative stability without interfragmentary compression. And يعني النقطة دي already في 2 lecture or 3 lectures مع بشندي وناقشت كثير جدا relative stability. So the colors form at the fracture site. طيب when does nail work as a load bearing device? As we know, it's characteristically is a load sharing device. Sometimes it works as a load bearing device in some fraction with axial instability that transmit all the forces applied to the limb in such fraction like comminuted fraction. In here, this nail is worked as in comminuted fracture, the nail working as load bearing device. What are the factors lead to this complication? Failure of this implant and non-union. Sometimes patient factor lead to non-union, like and lead to nail breakage, like smoking, alcohol, malnutrition, and so on. The biological causes for nail. And because the talk today about the biomechanical and biomaterials, so we concentrate mainly on biomechanical factors, like we discussed the anti-tensile strengths that talk by Bashendi, factor fatigue strength, stress riser concentration, nail diameter, using a hole, hollow versus solid nail, and etc. So we need to discuss about what are the forces working on the nail. If we have intramedullary nail like that, maybe the force is bending force that lead to this failure, bending force, or torsion force like this torsion force اللي هي this is the direction of the force working on the nail. يعني هنركز في موضوعين التورشن force والbending force. What the factors affecting the bending rigidity? Number one, the biomaterial. And here, young modulus of elasticity or stress strain curve. And this is discussed by Bashendi. And if we have a coupled chromium nail or titanium nail, has at twice the bending stiffness as that of titanium. ودي اتعرفت الستيفنس والtoughness والductility and so on. So one of the factors affecting the bending rigidity of the nail, the material of nail or biomaterial of nail. What do you mean by the stiffness? Stiffness is a material ability to resist elastic deformation, either bending, stretching, or twisting. When a force is applied, the slope of the curve in elastic region on stress strain curve in mean modulus اللي هي sorry this area. Stiffness also is defined as a slope of force versus displacement in graph. يا جماعة الفورس versus displacement in graph or changes the shape يعني consistent with the stress strain curve. Another factors after biomaterial structural factor. Here the length of the nail و second moment area or inertia. Second moment area or inertia. Here the geometrical property of a cross-sectional area measure it resistant to bending. سموها آلية القصور الذاتي أو مساحة القصور الذاتي تقريبا. هنا a second moment area of inertia it discusses the distribution of material في cross section area. The distribution of material في cross section area in relation to the axis. So if we have a solid circular nail يعني nail without any hollow area يعني nail مصمم, the bending rigidity is proportional to the force power of the nail radius. يعني at second moment area or inertia directly proportional to the force power. If we increase the radius by 2 millimeter, that means 2 millimeter أو force power of 2 millimeter أو 2 أس 4 معناه 2 ملم يساوي 2 في 2 4 في 2 8 8 في 2 16 يعني if we increase by 2 millimeter that means 16 millimeter increase in the resistance. طيب this regarding solid circular nail. If we have a hollow nail usually we use in orthopedic hollow nail. This is a hollow nail. In orthopedic usually we use hollow nail. Here it depends directly proportion to the force power of the outer radius minus the force power of the inner radius. This is the outer radius and this is the inner radius. So it proportional to the outer radius minus inner radius. دي بتدينا ال second area of moment of inertia or of area for hollow object or hollow nail. وليه الحكايه دي؟ لانه the second moment area depend على distribution of the material of object regarding to the axis or the long axis in the cross section. طيب now we discuss we said about the bending rigidity. عرفنا البايوماتيريالز وفي structural factor like the length والworking length هنتكلم عنه لقدام وعندنا second moment area. Regarding the torsional rigidity another force again the material properties تكلم عنها بشندي elastic Young's modulus and so on. هنا the structural property here we talk about the polar moment of inertia. هنا آلية الغصور القطبي تقريبا أنا ما قادر أترجمها لكن هي polar moment of inertia applies to cylindrical structure and its ability to resist torsion. A torsional rigidity is proportional to the force power of the nail diameter زيها or like the bending rigidity. طيب what are the second moment area and polar moment area? They describe nail resistant to bending and twisting respectively. And the greater material distribution away from the center increase the strength and the rigidity. The polar moment of inertia is greatly reduced in nail has slots. والnail has slots دي تتذكروها اللي هي like الكوشنر nail or الكينيل. We have a slot in Kushner nail وهي the polar moment of inertia is greatly reduced in this type of nail. What about the bending and torsional rigidity of hollow nail with open section؟ اللي هي open section like this. هنا عندنا hollow nail with open section زي الكينيل زمان. هنا very little difference in bending rigidity between a solid hollow nail and open nail has the same diameter. يعني bending rigidity no difference. For torsional rigidity the situation is different and is much greater effect. And here's a change in stress direction. كل القصة دي حاصلة due to this stress direction change. الستريس for torsion هنا with no slot دائما continuous. هنا change in direction of stress that leads to decrease the bending or torsional rigidity of this type of nail. What is the working length of nail؟ سأل منه مصباح هنا بنتكلم عنه أكتر شوية. The working length is the unsupported segment of the nail spanning the fracture side between the fixation point of the nail. ده واحدة من الديفينيشنز يعني. هو the unsupported part of the nail that is spanning the fracture side between the fixation point in the bone. يعني in other terms the distance between the distal screw of two proximal one and the proximal screw of two distal one. This unsupported area. This is the working length. What is the relationship? What is the relationship between the working length of the nail and bending rigidity and torsional rigidity? The bending rigidity of nail is inversely proportional to the square of its working length, as said by Mr. Huzaifa. When we increase the working length, we decrease the bending rigidity. وسع الواحد لو مسك أي شكل اسطواني اذا قل اللينكس او الطول بتاع الاسطوانه دي وداير يتنيها داير يعمل لها بندنج هتبقى اصعب. كل ما طول الاسطوانه كل ما زادت الامكانيه على انك انت تتنيها. So the bending rigidity is inversely proportional to the square of its working length. والtorsional rigidity is inversely proportional to nail working length. So a shorter working length means the greater the bending and torsional rigidity of nail. So stronger fixation. طيب what factor affect the working length? The fracture pattern, the fracture reduction quality, interlocking screw, and the reaming. Okay. And type of the loading force. طيب in the fracture pattern if you have comminuted fracture so the working length depend على interlocking screw. Sometimes we have transverse fracture and you ream the fracture and you do reaming for the fracture and use fitting nail. So here the unsupporting part of the nail because not the area يعني ما المسافة من two screws, the distance between the two proximal screws to the fracture side. Sometimes في contact between the nail and the bones, and these contacts reduce the working length. So the fracture pattern. If we do good reduction, we reduce the fracture at the working length. Using of interlocking screw, using the reaming, and also if the bone subjected for the bending. When the bending, that means lead to contact between the unsupported part of the nail with the bone and reduce the working length. طيب هنا اتكلمنا عن كثير we discuss about the bending rigidity, torsional rigidity and so on. What is the difference between rigidity and stiffness? Rigidity and stiffness are very similar concepts, often used interchangeably to denote overall performance of structure. We have two important distinctions between them. Stiffness is the material property resisting deformation. لو لاحظتوا in the first lecture in the introduction Mr. Medani used the term stiffness because we discussed about the material. So the stiffness related to the material property. But the rigidity is a structural property. يعني stiffness هنا in the material, if we talk about stainless steel, differ from the titanium, differ from the bone cement, differ from the cartilage and so on. But the structure, here we talk about the rigidity. In the structure, interlocking nail, solid nail, hollow with open sector, the Kushner nail, and so on. Here's the difference. Here we talk about rigidity. So rigidity is structural properly determined by both the material and the geometry, or in other words, the shape of the structure. Why do we use interlocking screw؟ بنسميها يا جماعه في بعض الكتب تلقوها بسموها البولز. And what function do they perform? They provide rotational axial stability. Then interlocking screws when using the nail. And allow iron nail to be used in more proximal, distal, and unstable fracture in highly comminuted in segmented fracture. يعني when the interlocking screw يعني created or يعني عملا increase the indication of using ultramedullary device. زمان classically use the Kushner nail used for transverse non-comminuted mid shaft femur fracture. إذا عندك أي type of fracture difficult to use nail. After appearance of interlocking screw or bolt, increase the use of or increase the indication for using the intramedullary device. We can use for more proximal fracture. يعني هنا diaphyseal fracture as indication distal fracture for highly comminuted fracture, segmented fracture, unstable fracture. What are the disadvantages of using interlocking screw? Technically demanding insertion. ويا جماعه الكلام ده كان في الماضي يعني عندنا اساتذتنا ربنا يطرحهم بالخير اتكلموا عن فتره من الفترات كان الانترلوكين نيل difficult to put the distal locking screw or interlocking screw. كان عيانين كتار بيطلعوا بالنيل ويزاوا الديستال سكرو. هسه افتكر الاصرار في بدايه الروتيشن بيتعلموا الحكايه يعني مشت القصه وبقت اسهل والناس اتعلمت السكيلز بتاعتها. لكن يعني theoretically كده او في الكتب بيتكلم عن انها هي technically demanding an insertion. Again, here we have hole for the screw in the nail, and this hole concentrates the stress, so it's called stress riser. Also, risk of screw and nail breakage. Usually, the breakage at the first case in the first slide, the breakage of the nail usually at the side of a screw hole. And so potential reduction in construct durability. When nailing a long board, how do you decide on how many locking screws to use? The number depends on the fracture location, comminution, and nail fitting. A stable fracture often require only one screw to do some rigidity for rotation just only. Mid-shaft transverse femoral fracture differ from the oblique, differ from comminuted, as do very proximal, as do very distal metaphyseal fracture. But stable mid-shaft fracture, we can use only one or single interlocking screw. How are locking screws different to other screw؟ اتكلمنا عن الكورتيكال سكرو وكده. هنا البولز or الانترلوكينج or locking screw differs. They are designed primarily to resist rotational stresses and provide stability rather than maximize the pull strength. The cortical screw عادي we have the threads وeffective thread diameter. هنا الeffective thread diameter بتاعتها very small لأن هي designed only to resist the uh, the torsional stress, not to resist the pull out strength. If you have this screw, 4.9 screw, the core diameter about 4، يعني دي less than 1 سنتيمتر اللي هي الثread diameter او الاوتر diameter. How can you reduce the risk of locking screw failure? Okay, use appropriate screw diameter, select suitable materials, avoid insertion defect, ensure proper surgical technique. Why not insert the largest locking bolt possible to reduce the risk of locking bolt failure? Larger bolts require larger nail hole, weakening the nail and increasing the risk of nail failure. Nail hole diameter should not exceed 50% of the nail diameter. يعني السكرو hole diameter should be less than 50% of the nail diameter. Key to takeaways: load sharing fixation promote healing. اللي هو الانترلوكين زي ما قلنا هو الانتراندول ده is a load sharing fixation device promote healing. Nail diameter strongly affect the strength. Shorter vertical lengths improve the stability. Interlocking screw enhance fixation but may create stress rider. Proper implant selection reduce failure risk. Thank you any question and thank you for attention.
Thank you very much يا دكتور محمد، جزاك الله خيرا.